Hello everybody. In this video we will be learning about exception handling and how do we implement that in our programs. So there are certain times or some situations that you face during the execution of a program that could have been handled in a better way, and you do not want your program to abruptly stop the execution because of some kind of errors that are occurring. For example, the error of division by zero, or maybe not giving the correct value for a specific data type and the data type does not match for the input value. So an exception is is an object that signals the occurrence of any unusual event during the execution of a program. And the process of generating an exception is called throwing an exception. So basically, with the help of exception handling, we try to avoid such situations during the course of program execution. The basic way of handling exceptions in C++ consists of a try, throw, and a catch threesome. So we basically utilize a try and a catch block, wherein in the try block we will put certain statements which could probably throw an exception. And if anything goes wrong, you can throw the exception utilizing a throw statement. However, if the code throws an exception, that can be dealt by utilizing a catch block which follows the throw block. The format that we utilize for giving a try catch block is something like this. As you see here, this is my try block and this is my catch block. Now here in the try block we will have some code to try which could possibly throw the exception. However, if the exception is not thrown, the execution continues with the more code below that. However, if the code throws the exception, in that case this exception will be caught by the catch block. So you do see one object of exception class here, and we will be getting into the next slides that what are the different kind of exceptions that can be thrown, and these are basically categorized under some different types. Now when the exception is thrown, what is the statement that you want to give as a reaction to the exception that has happened? So the statements within the try block execute just as they would if the block was not there. That means they just follow the order of their appearance. If no exception occurs and the try block completes, the execution will continue after the catch block. That means when there is no exception, the catch block does not execute. However, if the statement within a try block causes an exception of the type specified in the catch block, the remainder of the try block is abandoned and the execution will immediately transfer to the statements in the catch block. To understand this further, let's look at an example. If you notice in this particular code, what I'm trying to do is I'm creating a generic class. We did create this class in box.cpp. So I have one data member of type item, I have a set method, and I have, that means the mutator method, and I have an accessor method. I also have a generic function which is going to get parameters, which is an array of objects, the size of the array, and the target item or the object. So what is this function going to be doing is basically going to search the target object in the array of objects, and if it is found, it returns that object. So I'm utilizing a normal linear search method to find the target, in which case we just go in a linear fashion. We compare the target with the first element in the array. If it matches, we stop the execution there. If it does not matches, we compare it with the next element in the array and the next one, and so on until we've reached either the end of the array, That means my I starts with 0. This is for the index. So the loop continues till my I is less than size, or it would stop if the element is or the target is found in the array. So I have a if statement here. If bi is equal to if bi dot get item is equal to target dot get item, I simply change the value of the boolean variable found to true. Otherwise, it increments I, so that in the next iteration of the while loop, it will compare the target with the next element in the array. So now notice the way it is utilized here in the line number 40. Now how this is going to be working, the execution starts with main. Please look at line number 47. I make an array of strings, as you see here, of string objects to be precise, and I have two more objects created of type string. So I have a target and a result box. I'm setting the values of these 5 objects utilizing the mutator method in the class definition, and then I ask the user for the name that they want to search. After the value of the target object is set with this particular input given by the user, line number 58 to 64 is your try, catch, threesome. So we have try block here, and if you notice in the try block we always have certain statements which could probably throw the exception. So I say result box is equal to find box. So this is my place where the exception could be thrown. So this find box makes a call to the function definition. After the searching has been attempted on line 40, it says if not found, throw the logic error. This is a kind of an exception class which is there in C++ for any kind of logical errors. Now whenever you throw, utilizing a throw statement, the syntax we utilize is throw followed by the exception class, and in the parentheses you give a string that you want to utilize as a message, which could be utilized to be in informing the user that what actually went wrong. So here I'm saying element not present in the array. However, if the found was true, I'm returning bi. So when this throw happens, the execution continues with the catch block. And again, notice the syntax of the catch block. It has to have an object of the same class that you tried to create, throw the error for. So I said throw logic error. So here I'm saying logic error and the object name is LE for the parameter. And I say LE dot what. Now this what is basically going to extract the string that you utilize while throwing the exception. So this is actually going to display element not present in the array. Okay. So, however, if there was no throw executed, in that case, the function would return an object which gets plugged into result box on line 59, and then I use a accessor method to display that string. Now let's see how this basically functions. I have already executed the code. Now these are the names that I have. So let's search for the name Duke. Okay. Enter the name to be searched. I say Duke. It does say Duke is present in the array. I re-execute the code, and this time I give the name of any other name that I give which is not present. So let's try to give the name as Bob, and you do see element not present in the array. So if you do notice that the function is actually supposed to return an object, but of course if the object is not found, there's no way you could return the object. So I utilize a exception handling method to handle this problem, right? So going back to the presentation, if an exception has no applicable catch block, the execution of the method or the function will end, and the exception propagates to the client of this method or function. So you have, like we're doing here, since there was no catch block here, it propagates to the function which actually made a call to this function, which is here, and that is actually handled in the main function. That's what it means. Okay. However, if main would not handle it, it will still show, just give a runtime error. So you have to make sure that if an exception occurs in the middle of a try block, one more thing that you have to keep in mind, that the destructors of all these objects local to that try block are called. That means all the memory will get released eventually. So this is something that we have already discussed. Just one thing to keep in mind, that your catch block you do see has an object and a name of a parameter. So it looks like a function, however it is not a function, but sometimes you do relate it to a function definition. So the catch block parameter represents the actual exception object provided by the throw statement. That means, since in the throw I'm using a logic error as the exception class, so my catch should need to have that's how it basically releases that this is the catch block which is going to handle the exception which is thrown. As you can actually research on this or just try exploring more on this, that you could have multiple throw statements in a try block and you could have multiple catch also. So depending upon the kind of exception thrown, the respective catch is going to be eventually executed. Okay, so a catch block whose parameter has the type exception class can catch exceptions of the class exception class or any descendant class of the exception class. Specifying a catch block with a parameter of type exception catches any exception that can be thrown. Why? Because this is the hierarchy that we have. So C++ has two families of exceptions that a function can throw. You can select one of these. Now, one thing to keep in mind, it's only the logic error that you actually need to handle. Runtime errors, you do not have to utilize a try catch block and handle these errors because that is something which is not in your hands, right? However, we could handle logic errors. So if you're not sure about what is the kind of exception thrown, you could just use an exception class or you could use a logic error. But if you're specific about the kind of error that would be thrown, you could use the ones which are derived from the logic error right here. So exception class derived from runtime or one of its derived class are thrown by errors that are detectable only at runtime, such as division by zero or numeric overflow. If such exception is thrown, the program will halt just as it will when an assertion fails. However, the ones which are derived from logical error represents errors in the logic of the program, and such an unmet precondition or failure to satisfy an invariant or assertion that you could detect before the program executes. So for this we could utilize exception handling. All right. One more thing to keep in mind, that you could actually restrict a function with the kind of exceptions it could throw, and for doing so you need to have a throw clause in the function prototype. So you give the function prototype like one here, and after you close the parentheses for the parameters or the arguments, give throw followed by the exceptions that it could throw, and they could be separated by a comma. So here I just have one, so I'm just giving one. So a throw clause consists of the keyword throw followed by a list of its exception types separated by commas and enclosed within parentheses. So the reason I did not give that here, because I actually just defined the function straight. I did not give a prototype for this. All right. You cannot handle an exception of a standard class runtime or any of its descendant. However, you can handle exceptions of the logic error. These are you can get more into the different kind of logic exceptions and their derived classes. These are for the runtime exceptions. And when your function would be throwing an exception, it is always a good practice to document that by utilizing the Java doc tag at throws, that you specifies the kind of exception. And of course, if your function is having a probability of throwing more than one kind of exception, then the throw tag should be given for each exception in the alphabetical order of the exception names. So this will be all for this particular video.